Well, say if we take a look at the next rectangle phase 3 on page 339, there we basically have both getters and setters in there. So there we see class rectangle 3. I've got private double length, private double width. Those are two fields that are going to be used. And then I've got set length, and basically I'm passing in a double, and I'm setting the length to whatever we pass in, and I'm setting the width to whatever we pass in. It happens to be a W, and it's a double, and so we set the width equals to W. Then I have the get length and I have the get width. Now again, these are methods that we aren't passing anything in. I'm just saying, hey, now here's the trick. I'm returning length. So the set method must be executed before the get, which makes sense. So you have to use the setter before you can use the getter. So we could go ahead and run this, but it's not really going to do anything because it's just going to load each of those fields and then basically get data from each one of those fields. Well, I think I do. It's the length width demo. Sorry. So here's the length width demo. Let me do a run as. And there it's set to 10 and 20. So if we take a look at the length width demo, it's a main, so it means it's executable. And there I say rectangle 3 box is equal to new rectangle. So new rectangle 3. So what I'm saying is use the rectangle 3 class as my blueprint, and let's make an object from that called box. And we're going to instantiate it as a brand new one. And again, I keep harping on this. Those parentheses have nothing in them, and we'll talk about that just a little later on. So now I say box.set the length is equal to 10.0, and box.set width is now equal to 20.0. And then I can go ahead and say system print out, get length, and get width. Now, the great thing is I now have an object called box, and it has a width and it has a length. If I need to get the width or length, I can use that method get to get that information. Okay, so not too bad, not too bad at all. Now we continue on to the next. Let me just bring it up. I called it rectangle 4, and this one's a little different. It has everything the same except for, so let me back up. Here I've got my two fields, length and width, and then I've got my set length, I've got my set width, I've got my get length, and my get width. I have one more method though, and this method is called get area. Now this one I'm not passing anything in. I'm just saying, hey, I need the area of a rectangle. To get that, it returns the length times the width. So this is not a getter or a setter. This is an actual method that executes something with the data that already exists within that particular class. So if we take a look at the rectangle demo 4, it's a void main. Here I say rectangle 4 box is equal to new rectangle 4. So again, rectangle 4 is my blueprint. Box is the object. I'm instantiating it as a brand new. And I say box.set width is equal to 10. Box.set width is equal to 20. And then I basically print the box. So this is identical so far to the previous method or class that we saw a few minutes ago. And then I say the box's area is dot box get area. So pretty cool there. So let me go ahead and run this guy. And there we have the box length is 10, the box width is 20, the box area is 200. So kind of cool. So as you could see, we could use a scanner object, a keyboard scanner object, and actually ask the user to type in the length and the width and then basically return the area of that particular item. So as you can see, the box object now has a length and a width, and then it also has a method to get the area as well. So pretty cool stuff there. Now on page 344 it talks about the importance of data hiding, and that's when we make the fields equal private. And it says an object hides its internal data from code that is outside the class that the object is an instance of. If you hide an object's internal data by making the class's field private and making the methods that access those fields public. So, nice little paragraph here. It says, as a beginning student, you might be wondering why you would want to hide the data that is inside the classes you create. As you learn to program, you will be the user of your own classes, so it might seem that you are putting forth a great effort to hide the data from yourself. If you write software in industry, however, the classes that you create will be used as components in large software systems, and programmers other than yourself will be using your classes. Here's the important part. By hiding a class's data and allowing it to be accessed only through the class's methods, you can better ensure that the class will operate as you intend it to. So here's what that is saying, is if you made those fields public, then they could just use those fields and change them, and maybe you might have a setter that sets it a certain way, or it sets it in a specific manner, or maybe it sets it with some type of a calculation. If you made it public, they can set it any way they want. With a setter, you control how that field is going to get set. Okay, same thing with the getter. Okay, avoid stale data. The area is not stored in the field because it could potentially become stale. What that's saying there is we do not have a field called area. And the reason we don't have a field called area is because we might not execute that method getArea every time. We only execute that when we need to see the area. And so basically what that's saying is if I just use a setter to set the width and the length, and I don't ever call that getArea method, or let's say I call that getArea method and then I don't call that getArea method, and let's say I had a field called area. So if I created it and called it and I set that field, then the next time I run it I don't set the field, and the next time I call that field again it might not be the correct data. So again, use the method to just get what you need. Now let's take a look at the UML diagram. I'm on page 345, and let me go ahead and bring it up. So what this is doing now we're taking the UML diagram and we're making it a little more detailed. Now we're going to add pluses and minuses, and pluses mean public, minuses mean private. So now if I drew this UML diagram, rectangle, that's a class, and length and width are fields, I can see via the minus sign that they are private. And then I have plus, set length, set width, get length, get width, and get area all as public methods. Okay, so name of the class, fields, and methods. We could actually go a step further, and if I set the length I can do minus length and then colon double. So not only am I describing what's the viewability of that, it's private, but I'm also saying it's a double data type, so we can actually get that far as well. I think on the next page, yeah. So now let's take the UML a little bit further. So now I'm saying private field called length, it's a double data type. A private field called width, and it's a double data type. Now I'm saying a public method called set length. Now look at this. I'm passing in a field called len, and it's a double. I'm returning nothing. That's a void. Here I got set length, set width, passing in a w variable, it's a double, and I'm passing back nothing, void. This one I'm saying get length, I'm passing in nothing because there's nothing in the parentheses, but I'm returning a double. Get width, nothing in the parentheses, returning a double. Get area, nothing in the parentheses, I'm returning a double. So again, now if I were to read that, I now know how to code that. Okay. I don't know how to code get area because it's not described in there yet. So now if we saw a pound sign instead of a minus sign, that's protected. And protected means that it can be seen by the project but nothing else. There's no other areas that can see that. Okay, so yeah, I like this one over on page 347. And it basically says, here's a car class. I've got two fields called make and year model, both private. And here I have set make, set year model, set make, or get make, and get year model. So again, we would know right away what to do with that particular item. Now, we're going to throw a new term at you, and it's called instance fields or instance variables. And basically, we've already know what those are. So here is our class. This is called room area. So let me go ahead and bring that up. So here's room area. It's a void main. We got rectangle 4, rectangle 4, rectangle 4, so we're using a rectangle 4 class. Let me bring that up. So here's rectangle 4, and here's my two fields at the top. Those are called instance variables. Okay, they exist only during the instantiation of that particular class. We instantiate it and then place it into an object. Okay, so if we go back to room areas, so here I've created, now here's what's kind of cool. Now here's where it really kind of is showing its true its true coat of arms here. But here I've got rectangle 4. That's our class. That's our blueprint. I'm creating an object called kitchen. I'm instantiating as a new rectangle 4. Here I'm saying rectangle 4. Again, a blueprint. I'm creating a new object called bedroom. And the same thing with a den. So now I have 3 objects. They all have the same exact properties. They have the same exact instance variables. They have the same exact methods. And I say input, so I'm using a J option pane in this case. What is the kitchen length? And then I basically get that and I place it into a double number. And the kitchen.set length is equal to that number. And then put J option pane, what's the kitchen's width? Same thing there. And place the kitchen's width. I do the same thing with the bedroom and the den. So I'm asking the user for those widths and lengths for each of those rooms. And then I can come down here and say J option pane. So here we have the total area equals kitchen.getArea plus bedroom.getArea plus den.getArea. So this is kind of cool. I'm saying total area, which is a double, and it's equal to, so it tells it to go out and get the area of the kitchen, the area of the bedroom, the area of the den, and then we can go ahead and display that as the total area of those 3 rooms. So that's pretty cool as well. So each one of those is being returned as a numeric value, as a double in this case. So if we go ahead and run this, it's going to come up and ask me for, okay, what is the kitchen length? We'll go ahead and say 10, and the width is 15. The bedroom is 20 by 25, and the den is 25 by 30. And the total area of the rooms together are 1,400 square feet. So pretty cool there. Okay. So you can kind of start to see how we can kind of start putting these things together and create an object for each item, but they all use the same class. So I could have a car class, and I could create a Mustang, and I could create a Ferrari, and I could create a Chevrolet, and they're all using the same class as its blueprint.